Morning. Good morning, good morning, good morning. Good morning, good morning, good morning. Voice okay? I'm audible? Good morning, good morning. Okay. So, what's going on? So, last class I completed the thermometer where we are using the two reference temperature graph. Also I think I completed. So, two graph I discussed. I said nobody will mug up any graph. We have to what? We have to just know that how to plot. So straight line equation, how to plot the graph, that already I discussed. Up to that is completed now. Okay, so whatever graph I plot in the class, what I said, everybody has to reverse the axis and then you have to plot the graph. Then the x-intercept, y-intercept will change, slope will change. So that's why I said we will not mug up any graph. What we will do, we will know the, you know the equation. According to the equation, we will plot the graph, because maybe we are mugging by taking the Fahrenheit on the y-axis, Celsius on the x-axis, but they can give the reverse in the option. Okay, that's why we have to learn how to plot the graph. Okay. So one small question you will say then. Suppose I have given weekend syllabus is thermometry will be there up to the expansion of the solid. So here I gave the graph between any thermometer A, okay, scale A, and the degree C. Then I'm asking what is the relation between the reading of A and C, and options I have given like A upon T2 minus T1 is equal to C by 5, A minus T1 upon T2 minus T1, like that option given. Which option is correct? Somebody is saying 3, good, 3. So here if you see the graph, in the graph we can say when x-axis, what I said, on the x-axis y value is 0, on the y-axis x value is 0. So here for this point x is 0 means Celsius is 0. What is the y value we are getting? T1. At this point what you can write? 0 comma T1. It means Celsius is 0, y value is what? T1. Okay. Everybody got or not? It means LFP of this scale A. LFP of this scale A is T1. Okay. Now here temperature is what? 100. This point if I'm asking, so this will be what? 100 comma T2. It means when the Celsius is 100, then what is the scale A? Scale A is the T2. Okay. It means UFP of the scale A is T2. So LFP T1, UFP T2. Now we can use the TSI and we can equate the TSI, means we can say what? A minus T1 upon T2 minus T1 for the A, and the TSI for the Celsius is what? C minus 0 by 100. So answer is what? Third one. Everybody got? Completed? Okay. Now we completed what? When we are using the two reference temperature, okay, that type of thermometer we completed. But there was a problem when we are using the two reference temperature, okay, ice point and the boiling point. What was the problem? If suppose I am saying, what happens, what is the boiling point of water? First you will say, what is the boiling point of water? What is the boiling point of water? Tell fast. What is the boiling point of water? What is the boiling point of water? Tell fast. 100 degrees C. Okay. 100 degrees C, 100 degrees C, 100 degrees C. Very good. So now listen. Most of the students are giving the right answer, 100 degrees C. But one thing, I asked the boiling point of water. One thing I have not mentioned, but you assume that sir is asking in Celsius. I have not mentioned which scale. I ask only what is the boiling point of water, okay? But everybody assume that sir is asking in Celsius. That's why all of you are giving the answer 100 degrees C. Everybody got or not? One thing. Second thing, everybody assume that I am asking at 1 atmospheric pressure, okay? So two things you already assume. I only ask the boiling point of water. So two things has to arise in the mind. What? Which scale I am asking and at which pressure? Because by changing the pressure, boiling point also changes. Okay. But two things we are assuming. Suppose you are saying the answer in Celsius. Second thing, everybody is taking the pressure is 1 atm. That's why that is called 100 degrees C is called the normal boiling point. It is called the normal boiling point because it is at the normal pressure. Okay. And we are the normal people. That's why directly we are giving the answer normal boiling point. It is about 100 degrees C. Okay. So everybody got or not? So what we have learned, that we have learned at the 1 atmospheric pressure. When the pressure is 1 atmosphere, then the boiling point is the 100 degrees C. Boiling point of water is 100 degrees C. Everybody got or not? Up to this, okay? So boiling point depends upon the pressure. Later in the calorimetry, we will discuss what is a boiling point definition. Actual definition is what, like in the terms of vapor pressure, okay? But here we have to know what boiling point depends upon the pressure, okay? Everybody got or not? So boiling point, in short, boiling point increases with increase in pressure. Boiling point increases with increase in pressure, and boiling point decreases with decrease in pressure. Okay. This everybody got? What I said, this detail we will discuss in calorimetry also. So boiling point increases with increase in pressure. Okay. Inside the pressure cooker, we know that inside pressure cooker, food cook faster. Why? So inside the pressure cooker, pressure is more. So normal size pressure cooker, if we are assuming, so pressure is around 2 atm. Inside the pressure cooker, pressure more. So pressure more, then boiling point of water increases. So if you measure the temperature of the water inside the pressure cooker, boiling water inside the pressure cooker, it will around maybe 130, 140. So boiling point increases with increase in pressure. So inside the pressure cooker, pressure is more. So pressure is more, then boiling point increases. So water will boil at high temperature. So what I said, maybe 130, 140 like that, it will boil. That's why in the pressure cooker, food cook faster. Why? Water will be at high temperature. Water will be around, once water started boiling, now temperature is suppose 140. So your food will be always in the contact with the 140 degrees C. When it is on the open air, like you are boiling in the open container, okay, you are cooking the food in the open container. Suppose pressure is 1 atmosphere. So then water will start boiling at 100. When water will start boiling at 100, so food will be in the always contact with the 100. Inside the pressure cooker, it is always in the contact with the 140, and open vessel, it is always in the contact with 100. So when where it will get cooked faster inside the pressure cooker. So the ultimately aim is what? Pressure, what? Boiling point increases with increase in boiling point of water increases with increase in pressure. Okay. Same happen with the melting point, but reverse. In the melting point, what happened? On increasing the pressure, surrounding pressure, melting point decreases. Okay. So it means boiling point and melting point are the pressure dependent. So suppose I am making the thermometer to reference temperature, thermometer I am making. Directly proportional is the different thing. Okay, directly proportional means with what ratio? Like that's why we don't use this word, because otherwise sometimes it created the confusion. If I'm a small example, I will give who is saying that sir directly proportional to the pressure. Suppose I am saying, okay, y is equal to mx, y is equal to mx, where m is a positive. Can I say y directly proportional to x? If suppose I gave the relation y is equal to mx, this is the basic mathematics part, that mistake student do. Okay, what is the meaning of proportionality, directly proportional? So suppose I am saying y is equal to mx. Somebody said this pressure directly proportional to boiling point, that's why I'm explaining. If I'm saying y is equal to mx, so if m is positive constant, can I say y directly proportional to x? If I'm giving the relation y is equal to mx and m is positive constant, can I say y directly proportional to x? Again, I'm saying m is a positive constant. Can I say y directly proportional to x? I'm saying m is a positive constant. Can I say y directly proportional to x? If m is a positive constant, can I say y directly proportional to x? It means, okay, yes sir, everybody got y, m is constant, then I can say y directly proportional to x when m is constant. Okay. Another equation of line I am writing, y is equal to mx plus c. Okay. M is positive constant, c is also positive constant, suppose constant we are saying. Can I say, in the second relation, can I say y directly proportional to x? If I am writing y is equal to mx plus c in the second relation, can I say y directly proportional to x? If I am writing y is equal to mx plus c, m and c is a positive constant, can I say y directly proportional to x? No. Directly proportional relation means with what fraction or with what multiple you are changing the x, same multiple y is also changing. Okay. But in first and second relation, I can say what? Here proportionality is there. Like if I double the x, y will also get double. So here I can say y directly proportional to x. But here if I double the x, y will not get double. It will increase, but it will not get double. So here I cannot say the y directly proportional to x. So if anything is increasing with, suppose I'm saying y increases with increase in x. Y increases with increase in x. So I cannot always say without knowing means y directly proportional to x. That is okay. Y increases with increase in x. Like second relation, y is equal to mx plus c. Y will increase when x is increasing. But I cannot say y directly proportional to x. Directly proportional means if I double the x, which what multiple I am changing the x, same multiple y has to change. But no, why? Because c is also there. Are everybody got or not? So this directly proportional meaning everybody has to know, because these are the mistakes we are doing in the different places. Completed. Okay. So what I said, this we can say boiling point increases with increase in pressure. That is okay. But we will not use this directly proportional because we don't know exactly what is the relation. Are everybody got? So boiling point increases with increase in pressure and boiling point decreases with decrease in pressure. So what I said, the two reference temperature thermometer, in that we are taking the boiling point and ice point as a reference temperature, and their value are the pressure dependent. Okay. Suppose I am making the thermometer here. Okay. Suppose I am putting the mercury in the glass tube and I am making the thermometer here. When water started boiling, I put the thermometer in that and I wait for some time so that the water temperature, boiling water temperature and the mercury temperature become same. So wherever the mercury is pointing, I will mark as a boiling point as 100 degrees C. Same I will do for ice point. Okay. So when water started boiling here, I assume that pressure here is 1 atm, and then I mark the boiling point as 100. But one thing exactly, I don't know what is the pressure here, and maybe the different places pressure is varying also. Same thermometer you are making in the hilly area. Okay, suppose Himachal Pradesh, Shimla, then there it is at height. Due to the height, what will happen? Pressure will be surrounding, atmospheric pressure is less, so water will start boiling at 70 degrees C, 80 degrees C. If I'm making the same thermometer, I put the I put the water in the open container, and when it start boiling, then I mark as boiling point. Okay, but what is the boiling point there? There water will start boiling at low temperature like 70, 80. But that we don't know, means what is the pressure exactly there? Everybody getting my point or not? So means boiling point and melting point, they changes with change in pressure, and where we are making the thermometer, what is the pressure there and all, that is the problem. Okay, so that's why there was a problem in the two reference temperature, because the boiling point and the melting point changes with change in pressure. So different place, pressure different, so boiling point will be different. Okay, that's why we are not using the two reference temperature in the modern thermometry. This question given in the NCERT also in the exercise, why we are not using the two reference temperature thermometer. So assertion is it is a good question. Suppose they are saying assertion, they are saying two reference temperature are not used in the modern thermometry. What is the reason? Because boiling point and ice point are the pressure dependent. Everybody got or not? Completed? Everybody understood? Anybody has doubt? Okay, so this point you have to remember. Okay, now if we are not using the two reference temperature, then what we are using? Okay, so we are using what? Triple point of water. That's why I have written triple point thermometer. We are using, in the place of the two reference temperature, we are using only one reference temperature, that is a triple point of water. Okay, triple point is what? Maybe you know, it is a condition of the temperature pressure when the three state of the water exist together. But in detail we will discuss in calorimetry. So triple point of the water is 273.16 Kelvin or 0.01 degree C. Okay, so we are taking the triple point of water as a reference temperature in the modern thermometry, and only one reference temperature we are using. Okay, everybody got or not? Why we are using, I said what, two reference temperature, there is a problem. So we can say what, in modern thermometry we are using triple point of water. In Kelvin, what is the value? 273.16 Kelvin, or in Celsius we can say 0.01 degrees C, because 0 degrees C is equal to what? 273.15. Here 0.01 is the extra. Okay, so this is a triple point of water. So triple point of water is used as the reference temperature. Everybody got? Now if I am using the triple point thermometer, so I cannot use the TSI, because TSI we define for the two reference temperature, LFP, UFP minus LFP, like that. Okay, so we will not use the TSI for the triple point thermometer. Everybody got? So for the triple point thermometer, what we will use? Like Charles law of Gay-Lussac law, TTR is equal to so for triple point thermometer we will use this relation, T upon TTR is equal to X upon XTR. What is the meaning of the TX? So X is what here? X is the any property that changes with temperature, like pressure of a gas, volume of a gas. So here X we can take either pressure or a volume. Okay, everybody know the Charles law, later that also we will discuss. So for triple point thermometer we will not use the TSI. Which relation we will use to find the temperature? T upon TTR is equal to X upon XTR. Okay, now what is the meaning of the symbol here? TTR is the TR means triple point. So it is a TTR means triple point of water. So it is what? Triple point of water. Okay. Here we will take the triple point of water, whatever scale they given. Okay. Here XTR. XTR means here pressure. What I said. X is the thermometric property. X is the thermometric property means like pressure, because pressure of a gas changes with change in temperature. Suppose I am saying at constant volume. So we have at constant volume of a gas, then we can say pressure is directly proportional to temperature. So I can take the, in the place of X, I can take the pressure. In the place of X, I can take the volume according to the problem. Like I am taking the pressure constant, gas pressure is constant. Then I can say volume is directly proportional to temperature. If I am saying the volume is constant, then pressure directly proportional to temperature. So X we will take accordingly, pressure or volume. Okay. Everybody got? So T upon TTR. TR is what? Triple point of water. X we can say either pressure or volume. Are everybody got or not? So XTR means pressure of a gas or volume of a gas at the triple point. Pressure of a gas or volume of a gas at triple point of water. Okay. X means what? Suppose I want to measure the room temperature. I want to measure the room temperature. Okay. Okay. So I have taken the triple point thermometer. Now in the room, what is a gas here? Air basically. Okay. So suppose I know the air pressure. I know the air pressure at triple point of water. I know the air pressure at triple point of water. So I will put the PTR. PTR means air pressure at triple point of water. Here I will put a triple point of water. Here triple point of water. Here I will put pressure of a air at triple point. Okay. I want to find the room temperature. I want to find the room temperature. So here I will put the what? X I will put what? Room pressure. I will put X is equal to what? Room pressure. So I will say what? P upon PTR. P upon PTR. And then here I know triple point, I know triple point of water, I know pressure of a air at the triple point I given. Okay. Room pressure they will give. Okay. So room pressure we know, from that we can find the room temperature. Everybody got or not? So what is the meaning of X? X is the pressure or thermometric property at the temperature T. XTR is what? Thermometric property at the triple point. Okay. So in the front you can remember. Here triple point, here thermometric property at triple point. Here unknown temperature, here the pressure given at the, which temperature we want to find. X is the thermometric property at that temperature. Okay. So for the triple point thermometer, we will not use the TSI. For the triple point thermometer, we will use this relation. Okay. Should I repeat again? So what I said? Triple point of water, thermometric property at triple point. Okay. Any thermometric property at any temperature they given here, according to that we can find the temperature. Okay. Okay. So one question given in the NCERT exercise, that question definitely any year they will ask. Okay. They given what? We have the 2 scale. Okay. Then find relation between reading of A and B at given temperature. So what given here? 2 temperature scale A and B, in which triple point of water is 200 degree A and 350 degree B. Then find relation between reading of thermometer A and thermometer B at a given temperature. Okay. So what is the meaning of question? I said same temperature when we are measuring, like body temperature, suppose we are measuring. So our body temperature is the unique, that is the one. But when I'm using the different scale, reading will be different. Like I'm measuring my body temperature by Fahrenheit scale, it will measure 98.5, 98.6 around. If I'm measuring my body temperature by Celsius, so that will be around 36.6, okay. But ultimately my body temperature is constant. So reading can be different. Reading will be different for the different thermometer. So here they are saying I'm using the two thermometer A and B. Two thermometer A and B, in which triple point of water is what? In the scale A, it is a 200 degree A, and in the scale B, it is a 350 degree B. Okay, this data everybody got. Now they are asking the for any temperature, what is the relation between the reading of the A and reading of the B? Like suppose I am saying for any temperature, what is the relation between the Fahrenheit and Celsius? Then you will say, sir, F is equal to 9C by 5 plus 32. F is equal to 9C by 5 plus 32. So that is the relation between the Celsius and Fahrenheit for any given temperature. So same they are asking, what is the relation between the reading of A and reading of B at a given temperature? Question everybody understood or not? Okay. Now suppose for A first I am saying, for any temperature, reading of A, suppose I am measuring the room temperature. I am measuring the room temperature. Okay. So for room temperature, reading of A is, suppose I am taking TA. Reading of A I am taking TA. Okay. Room temperature, suppose I want to measure by using these two thermometer A and B. And reading of A is TA. Okay. Upon triple point of water. Triple point of water in the scale A is what? 200. Okay. So this I said what? Suppose I am measuring the room temperature by the thermometer A and B. So reading of the thermometer A is what? TA for the room temperature. Upon triple point of water in the scale A is what? 200. Okay. Now if I am saying room temperature, I am measuring the room temperature and I am suppose taking the pressure as the thermometric property. So room temperature means right hand side I will take room pressure. Right hand side what I will write? Room pressure. I'm just taking the example. So I will take room pressure. Upon what I will take? I will take the pressure of the gas at triple point of water. Okay, denominator what I will take? Pressure at triple point. Okay. Same I am doing for the thermometer B. Okay, so thermometer B, suppose room temperature reading is TB. Room temperature reading is TB. Okay. Then upon triple point of water in the scale B, that is what? 350. Okay. Is equal to. Now I am measuring the room temperature. So for B also pressure I will take room pressure. So right hand side I will take what? Pressure, room pressure. Okay. Upon pressure at triple point of water. Reading can be different for the triple point, but the pressure of the air will at the room pressure of air at the triple point will be constant. That's why here I am taking PTR, here I am taking PTR. Now if you see these two relation, right hand side is same, right hand side is same. So I just took the example of the room. Whatever the pressure, whatever the temperature you are measuring, right hand side will be like this, right hand side we can say same. Okay, it means I can directly say TA by 200 is equal to what? TB by 350. TB by 350. Now from this what you will get? 0, 0 cancel out. This 7s are 5 and then 4s are. So then what you got? TA is equal to 4 by 7 times of TB. This is the relation between the reading of A and reading of B. Like suppose I am saying B is measuring the temperature 7 degree B. B is measuring the temperature 7 degree B. Then what is the reading of A? Then I can say 4 by 7 into 7, that will be equal to what? 4 degree A. So that is the meaning of the relation between the reading of the thermometer A and thermometer B. Everybody got? So how to use that triple point thermometer? Everybody understood why we are not using the two reference temperature? Everybody got? Okay. So next topic is what? Thermal expansion. So what is the meaning of the thermal expansion? So we know that, and we observe in the practical life also. When we increase the temperature of any body or the material, then what happens? So basically in any material, any body, the smallest unit is the atom or the molecule, we can say, and the atoms are arranged at some distances, okay, in different body. Like solid, the distance between the atoms will be small. In liquid it will be a little bit more, okay. So any body is made of the atom. Now there is some particular equilibrium distance between the atoms, okay. When we are increasing the temperature, when we increase the temperature of any body, then what will happen? There all the atoms or molecule thermal energy will increase. Their temperature will increase, so their thermal energy will increase. As their thermal energy will increase, they will start vibrating with more amplitude. When they will start vibrating with more amplitude, they will go far from each other, so the atom distances will increase. Now atom distances increase, so overall the total, like whole body will get expand. Like this is happening in the thermal expansion. Everybody got or not? Means what is the meaning of thermal expansion? When we increase the temperature of any body, then body volume increases. If it has a two-dimensional body, we can say area increases. If it is a linear object, we can say length increases. So we can observe in the practical life what I said. In winter, when the temperature of the temperature is less, then you can see the wire, electricity wire, that will be tight between the poles, okay. But in the summer, what happened? They become loose. They become loose. That's why if you have to put the wire in between the two poles. So put in the what? Summer you will put or winter you will put. Suppose summer you put it tight. Okay, summer if you put the wire between the two poles are there, and you put the wire in between. In summer you put the tight. Okay. Then in winter what will happen? It will contract because the temperature of the surrounding is less. Temperature decrease, so it will contract. When it will contract, it is possible that it can get break also. Okay. But when suppose you put in the winter wind means temperature of the surrounding less, you put tightly between the two pole. Okay. Now in summer what will happen? It will get expand and it will get loose like this. Okay. So you can see also in the summer days wire become loose. Okay. Because of the thermal expansion. In the railway track also we make some gap in between the tracks. Why? Because in the temperature is more, then what will happen? Track will get expand. If that gap is not there, so it will get distorted. And in the India, maximum 60 to 70% train accident is due to this reason only. Rail track de-alignment means due to that expansion it happens, and then most of the train accident happen. Okay, so all these reason is what? Thermal expansion. So thermal expansion, what I said, means when the temperature of the body increases, so its size will increase. So that is called the thermal expansion. According to the dimension of the body, we can divide the thermal expansion into the three parts. One is what? Linear expansion. Second is what? Aerial. Superficial or aerial expansion. Next is what? Volume expansion. Okay. So like one-dimensional body, two-dimensional body, three-dimensional body, accordingly that we can find the linear expansion, aerial expansion and volume expansion. Okay. So first one is what? Linear expansion. So a small example I am taking, suppose linear expansion I want to define. I am taking one wire or rod. Okay, one wire or rod I am taking. In that, suppose I am assuming in one line, this is a wire or rod. In one line, there are the 100 atoms are there in a line. Like then 100 atoms are arranged, 100 atoms are arranged. One example I am taking. So suppose I am taking the one rod of any length. In that 100 atoms are arranged in a line. Okay, then next line 100 atoms. Like this, they are arranged. Okay. and distance between the consecutive atom will be something. Okay, again I'm saying one wire or rod I'm taking, and I assume suppose there are the 100 atoms are in a one line. Okay, whatever the length I took, in that 100 atoms are in a one line. Okay, and at distance between the consecutive atom will be the constant, that is called the interatomic distance. Okay, now there are the 100 atoms means like this they will arrange. When I increase the temperature, if I increase the temperature of this rod, so when I increase the temperature, what will happen? All the atoms, distance between the consecutive atom, all the atoms distance will increase. Why? They will start vibrating with more amplitude and they will arrange at the more distance. Okay, so what will happen when we increase the temperature? Distance between the consecutive atoms will increase. So suppose I said the total 100 atom chain is there. Okay, then each atom distance, consecutive atom distance increase by x. It increased by x. So then one distance between consecutive atom increased by x. So total 100 atoms chain is there. Then x, then other next consecutive x, next consecutive x. Then what is the total increase in the length? Then what is the total increase in the length? 100 atom chain, that is a mathematics, you will say the 99 pair we will get. So then I'm not going to that. Approximately what you can get, 100 chain is there, 100 atom chain is there, 99x, very good. So 100 atom means consecutive means total, we can make the 99 pair. But that much of mathematics I'm not going, just take the 99x or 100x. So suppose what I said, distance between the consecutive atom is increasing, then each atom consecutive atom distance increase by x. So next also x, next also x, like that way. Suppose 99x, total increase in distance is 99x. Okay, this everybody got or not? If I am taking the more chain of atom, more chain of same material, I am taking the more chain of atom. Suppose I am taking the 200. Then what will happen? Distance length increase will be more or not? Because if 100 atom chain is there, I am getting the 99x. When 200 atom chain is there, I will get the more elongation. So that's why what we are saying, change in the length is directly proportional to the original length. If I am taking short, suppose this pen I am taking, so maybe in this I got the elongation delta L1. If I am taking the bigger pen, then more number of the atom will be there, then elongation will be what? More. Everybody got or not? So if temperature of rod or wire change by delta theta, then one thing we can say, change in length. Change in length, delta L is directly proportional to L. What is the L here? Original length. Or natural length. Okay, so delta L is directly proportional to the L, we can say, where L is the what? Natural length at a given temperature. Means you are taking the more length, you will get, then we will have the more elongation. Okay, if you are taking short length, then we will get the less elongation accordingly. Okay, so we can say what? Elongation or change in the length produced in the rod or wire will be directly proportional to its natural length. Okay, this everybody got or not? Now second thing, if I increase the temperature more, same pen, if I am increasing the temperature 10 degree and I am increasing the temperature by 100 degree. So when I increase the temperature more, length change will be more. Okay. So second thing we can say what? Delta L is directly proportional to delta theta. Delta L is directly proportional to delta theta. Delta, already I said, delta means what? Final minus initial. Always delta we will take final minus initial. Okay. So delta L is directly proportional to delta theta. Means we are changing the temperature more, change in the length will be more. By combining them, what is the relation we will get? Delta L is equal to L alpha delta theta, where alpha is the proportionality constant. After combining both, we are putting the one proportionality constant alpha. So what is the formula we got? Delta L is equal to L alpha delta theta. This is the first formula that you have to remember in the thermal expansion. Okay. Everybody got? So delta L is equal to L alpha delta theta, where L is the natural length, delta theta is the change in temperature, alpha is the proportionality constant. What is the alpha? Alpha is the proportionality constant, and alpha is called coefficient of linear expansion. Yes. So alpha is the what? Proportionality constant, that is called coefficient of linear expansion. Okay, so it is a proportionality constant. So it is called the and what it is called? Coefficient of linear expansion. So one formula, what I said, we have to remember delta L is equal to L alpha delta theta. Up to this, okay? From this, if I am saying alpha, then alpha, what I can write? Delta L by L into delta theta. Okay, alpha, what I can say? Delta L by L into delta theta, or if you required in the differential form, then alpha we can say what? DL upon L into d theta. Completed? So small thing, suppose I said length I double the length of the wire or rod. What is the effect on the alpha? If I double the length of the rod, then what is the effect on the alpha? If I double the length of the rod, then what is the effect on the alpha? If I double the length of the rod, what is the effect on the alpha? Constant. Very good. If I double the length, I said very good, then I got the wrong answer. Decrease by 2. Well, length get double, then delta L will get double, because we have written what? Delta L is directly proportional to L. That is the meaning of proportionality, what I explained earlier. Delta L is directly proportional to L, means L double, delta L double. L triple, delta L triple. Okay. So here L is direct, L double, then delta L double. But ultimately alpha is the proportionality constant, or alpha will not get affected by the L. Everybody got or not? So alpha value depends upon material. For given material, it is constant at a given okay. So what I said, alpha value depends upon material. For the given material, it is constant at a given temperature. Like I'm saying copper. So copper will have its own value of alpha. Okay. Silver, copper, aluminium. So alpha value depends upon the material. Okay. It will not change with the changing the length. Okay. Are everybody getting or not? So what I said, alpha value depends upon the material, and for the given material, it will be constant at a given temperature. Now one small question I'm asking. Okay. Suppose in the question they given what? Alpha value depends upon. First option I am giving, suppose length of the rod, length of the material. Alpha value depends upon the length of the material. Okay. Or second option I am giving the temperature. Third option I am giving the material. Fourth option I am giving none. So what is the right answer? Alpha value depends upon, first I am giving size of the object. Second I am saying temperature. Third I am saying material. Fourth I am saying none. Then answer is what? Material. Then answer is material. Okay. Now same question I am asking. Alpha value depends upon. Alpha value depends upon. First option I am giving size of the body. Second option material. Okay. Third option I gave material. Okay. So again I am repeating. Alpha value depends. Next question I am asking. Alpha value depends upon. First option is size of the body. Second option temperature of the body. Third option material. Fourth option both 2 and 3. Fourth option both 2 and 3. Then what will be the right answer? Alpha value depends upon first option size of the body, second option temperature, third option material, fourth option both 2 and 3. Both 2 and 3, then will be the answer. Listen why. First thing, for numerical problem, listen carefully. For numerical problem, we will take if they given the material same, we will not consider that what is the temperature of this body. We will take for numerical problem, if they are saying the material is this, same material, then alpha we will take constant, because we cannot say how the alpha changes with the change in temperature. Okay, so for numerical problem, suppose I am saying copper sphere is melted and it made the copper rod, then copper to copper means ultimately whatever the temperature is there, we will take the alpha constant in the numerical problem. Okay, theoretical question, two way we can ask. First I ask what? I have to select one option. Then more appropriate is what? Material. Okay, but everybody know that material property changes with change in temperature. Like a small example, suppose you are taking the gulab jamun in the sugar syrup. When it is a temperature is less or it is a chilled cold, then you can see that sugar syrup will be thick. But when we increase the temperature, then it become what? It become the thin. Okay. So properties, or we are heating the material. When we are heating the material, what will happen there? Interatomic distance will change, the forces between the atoms will change. Then what will happen? Material property changes with the change in temperature. So more appropriate is what? If theoretical question this type of option is there, it depends upon the material and its temperature. So better option is what? We have to select this. What? Material and its temperature. But what I said, numerical problem, whatever the temperature they are giving, copper they are saying 100 and we change the temperature up to 500, we will not think that to change the value of alpha, what is the value of alpha, we have to take same material given alpha, we will take constant in the numerical problem. Otherwise they have to mention how alpha is changing with the temperature. Everybody got or not? So in the NEET in the 2016, they asked the graph also. Later I will discuss the graph also. Alpha for the copper, how it varies with the temperature. That graph is there in the NCERT in 2016. That graph directly they ask. Okay, so that graph shows what? Alpha for the same material is not constant. It changes with the change in temperature. So for theoretical question, appropriate option is what? Material and its temperature. But only one option we have to select. Then we will go to the material. Up to this, okay? A little fast. Okay, so this completed. So alpha value, okay, it depends upon the material, and at a given temperature we will take for the material, it is a constant for numerical problem. Okay, if I am saying what is the unit of alpha? What is the unit of alpha? Tell fast. What is the unit of alpha? Unit of alpha. Tell fast. So unit of alpha, what we can say? Delta L and L. Delta L means length unit. L length unit. Length unit upon length unit cancel out. But delta theta will remain. It means alpha unit is what? 1 upon delta theta. 1 upon delta theta unit. Delta theta unit is what? Either degree C or Kelvin or what? Fahrenheit we can say. So unit of alpha is either we can say per degree C or per Kelvin, or we can say per degree Fahrenheit. Okay. Next thing about alpha. If I am saying two rod, identical rod I am taking, but made of different material. Two identical rod means initial length are same. They are made of different material, and I am changing their temperature by the same amount. Two identical rod means same length rod, two same length rod made of different material. I am changing their temperature by the same amount, means delta theta is same for both rod. Which rod will expand more? So listen, if alpha more, you can see L, so what I said, L same, delta theta same. So whose delta L will be more? Whose alpha is more? So what we have to remember, which material has the more value of alpha? It will expand more on heating and it will contract more on cooling. Again, I repeat again. Okay, so which rod will expand more? Which material has the more value of alpha? More value of alpha, more expansion on heating and more contraction on cooling. Okay, so alpha more, so contraction will be more when you are decreasing the temperature, and expansion more when you are increasing the temperature. Everybody got? So third point about alpha. So which material has more value of alpha? It will expand more on heating and contract more on cooling. Okay, so this point is clear to everyone. Completed. Next statement, what I'm going to say, that is the only for theoretical question you will do. Otherwise, alpha always we will consider the positive quantity, and temperature increase we will consider the expansion, temperature decrease we will consider the compression. Only if theoretical question they are saying a material, if any material contract on heating, then what is the value of alpha? We can predict the value of alpha. It is a very large positive quantity, it is a very small, and it is a negative. So for theoretical, otherwise alpha we will never consider negative. But what I said, only theoretical question you have to just suppose this type of question they are asking. So if they are saying any material contract on heating means delta L is negative, heating means delta theta is positive. So how it is possible? When alpha will be negative. So if theoretical, otherwise what I said, we will never consider sir alpha is negative. Only theoretical question just to have to remember. If they are saying any material contract on heating, it means its value we can take negative. Its alpha value will be negative. Got it or not? Tell fast. So if, because most of the material we are learning the thermal expansion, means when we will increase the temperature, then the body will expand or material will expand. But theoretical question, just I am saying, otherwise what I said, don't get confused, sir, alpha they may not mention negative or positive, sir, I have to take the negative alpha or positive alpha. Nowhere you will think this except the question if they are saying. If the material contract on heating, then what we can say about the alpha value. Okay. Completed. Now this formula we are getting delta L is equal to L alpha delta theta. Here two things we have to think their sign, plus and minus. Suppose I am saying on increasing the temperature or changing, I have not mentioned heating or cooling. I am saying on changing the temperature, length of the rod increases. On changing the temperature, length of the rod increases. So delta L is positive or negative? Now alpha positive negative, you will not think alpha always we will take positive. Okay, now here what I am saying, if I am saying by changing the temperature, length of the rod increases. So delta L is positive or negative? Positive. Delta means what? Final minus initial. If I am saying length is increasing, okay, length increases. then delta L is positive, and if length decreases, then delta L is negative. Okay, so if I know about the expansion or contraction, so I will put the delta L accordingly. If I'm saying rod is expanding, length is increasing, so delta L I will put positive. If I'm saying length is decreasing, then delta L I will put negative. When I'm putting the sign of delta L, delta theta sign I will get automatically. Like delta L I put positive, so delta theta will be positive. It means body is heated up. What I said, don't think that sir alpha can be negative. Okay, so what I said, delta L is length is increasing, delta L is positive. Delta L is positive, so delta theta will be positive. If I'm saying rod contract, then delta L I will put negative. When I will put delta L negative, then delta theta will be negative. It means rod is getting cooled down. Means temperature of the rod is decreasing. So one you have to put with the sign, other delta sign you will get automatically. Suppose I said rod is heated. Rod is heated means delta theta positive, then delta L will be positive. It means length of the rod will increase. If I am saying rod is getting cooled down means delta theta is negative. Delta theta is negative, then it means then delta L will be negative. Delta L will be negative. It means the rod will get contract. Okay. So once you have to put with the sign, other variable will give the sign. Other variable automatically will get the sign. Okay. Completed. Okay, one more last thing. We will not mug up the final length directly. Suppose I am saying after changing the length, what is the final length? So final length, first we will only directly apply the delta L formula, and we will remember the delta L formula. Okay. Final length, if I am saying, so final length I can say what? Initial length plus delta L. Okay, if delta L you are getting positive means final length will be more, delta L you are getting negative, so final length will be less. So L plus delta L. So L final, what I can say, L plus L into alpha delta theta. Then L final, what I can say, L into 1 plus alpha delta theta. Just that is a formula I am writing, but no need to mug up. Delta L formula we have to remember, and directly L plus delta L, by that you will get the final length. Okay. Completed. Why I'm explaining these small things, sign and all, because of the sign mistakes, you will everything formula, everything you will write correct, but you are putting the variable sign opposite, then whole answer will get what? Change. I will show some example also. This completed. Next thing, suppose I am saying fractional change in length. So fractional change means, fraction means in a 1. Okay. So fractional change means fractional error, fractional change. In whole chapter, every chapter of physics we will use this. Fractional change means change upon original. Okay. Fraction means in a 1. So length L changes delta L. So in one length, how much change? Delta L by L. So fraction means in a 1 we are defining. So when the length of the rod is L, changes delta L. When the length of the rod is 1, then what will be the change? Delta L by L. So fractional change means delta L by L. And delta L by L, what I can say? Alpha delta theta. Okay. So if they are asking the fractional change in the length, then it is what? Delta L by L. And percentage they are asking, so just we will multiply with 100. Okay, so percentage change means delta L by L into 100 or alpha delta theta into 100. Okay. Tell fast. So small question I am asking. Completed. So this is the very common. On increasing the temperature, if temperature increase, which quantities will increase, which quantity will decrease? One distance I have shown x, one, this is the, like suppose I am taking the, it is like a ring, here it is a material, okay. I am saying when the temperature of this ring increase, annular ring we can say, so then which quantity increases, which quantity decreases, whatever I have shown. This thickness I have shown D, this thickness I have shown D. Here it is a D. Tell fast. What will happen with R? D decreases, Y decreases, X increases, okay. One answer I got, D decreases, Y decreases, X increases. Theta and R increases, okay. Y decreases, X increases, D decreases, and R increases. Okay, what about theta? Angle does not change. Okay, R increases, theta decreases, R increases, theta decreases. Means mixed answer I am getting. Somebody is saying some quantity correct, some are wrong. Means nobody is giving all quantity correct. Okay, now listen. One thing I said in the linear expansion, suppose we have the 100 chain of the atom, then each atom distance will increase. So whenever we are, so who is saying Y decreases, theta increases, decreases, what they are thinking, I will discuss later. So what I said, when the chain of molecules are there, or chain of atom is there, all atom will go far from each other. So overall we will see the expansion, okay. So you are thinking that what will happen, it is like this. Now when it will expand like this. This part will go closer, this part will go closer, like you are thinking like this, okay. But all the atoms, they will go far from, like consecutive atom distance will increase. So after expansion, what will happen? It will be like this. Okay, so one by one I am saying x means what? It is the distance between the 2 points, 1 point here, 1 point, one material point is here. What I said, atom distance will increase. So when the size increases, here is a thermal expansion, okay. So size increases, means what will happen? X increases. Everybody got or not? This everybody understood or not? Because it is a expanding, means its size is increasing. X, suppose I am saying what is the final value of X. So X final, I can say what? X is the linear distance. So any linear distance, I can apply the linear expansion formula. So X final, I can say X into 1 plus alpha delta theta. Okay. Here delta theta, this angle I am taking alpha, otherwise you will get confused between temperature and angle. So here angle I am taking alpha. Okay. So here I can take alpha delta theta. This everybody got. So X will increase according to the linear expansion. Okay. Now come to the radius. Radius is also what? Linear, like what? Linear dimension. So radius, new radius, what I can say? Again, the radius will also be 1 point center. Center is fixed, but this point is going far. So radius will also change by the linear expansion. So R final, what I can say? R into 1 plus alpha delta theta. Okay. So radius also increases. These two everybody got or not? Now who is saying D decreases? They are thinking that if the size will increase, material will what? Size increases, volume increases, so thickness will decrease. But ultimately here we are saying material is not like you who is applying the volume conservation. You are thinking this increase, this thickness decrease. But here volume is changing. Volume is not constant. Okay, whole material is expanding, means distance between the consecutive atom is increasing. So whole material is expanding. It means distance between the two atoms here and here, this and this. That distance will also what? Increase. So D will not decrease, means size increases, so it will become thin. That will happen when the, suppose I am saying that type of question we are doing when suppose you have the wire. Okay, any wire you have, And now in the current electricity, we are doing this type of problem. We stretch the wire, we elongate the wire. So what we are doing, when length increases, then we are taking the radius will decrease, area will decrease, but the total volume will be constant. Okay, that type of question we are doing. Then there we are saying the length increases, so radius decreases. But here what is happening, due to the temperature, whole material volume is increasing, material is expanding. Okay, so I will not take that this size increase, so this will become thin. Are everybody got or not? So D is also the distance between the 2 points in this ring, that will also what? Increase. Okay, so D also increases, so D will increase. So D final, I can say it is also the linear dimension, D into 1 plus alpha delta theta. These three variables clear to everyone? Okay. Now who will say, three I discussed, who will say about Y? What is the effect on Y? What is the effect on Y? Increases, decreases, remain same, what? What is the effect on Y? What is the effect on Y? When size increases, this point will also go far, these two. Y also increases. Y also, because this, and now it is becoming like this. So this point also goes far from each other. Okay, not same. It will also increase. Because it is not going like this. It is expanding like this. Who is saying decrease or something? So they are thinking that it will go like this. But it is expansion, means it is going size, whole size increases, means it is like this. It is like this, so Y will also what? Increase. Everybody got? Okay, so Y, I can say Y will be what? Y also increases. Y final, it is a linear dimension. I can say Y into 1 plus alpha delta theta. Okay. Now for angle alpha remain same. Why? Because angle is equal to completed. Now listen, alpha, if I am saying angle is equal to, we have learned the formula, angle is equal to arc upon radius, angle is equal to arc upon radius. So if initial angle I am finding, alpha, then you will say what? Arc, what you will take? Y by R, Y by R. Are nalayak, sir, ultimately is volume initial and final are same or different? Volume expansion is also there, na? Volume is increasing, material volume is increasing. Here same material means we are not keeping the temperature same, means total volume is constant. If I increase the length, then area will decrease. Here volume is also, because distance between, suppose I am saying this is the sphere, okay, Vardhan, suppose this is a sphere, okay, different points are there in this, okay, sphere. Now when I increase the temperature, what will happen? Distance between each atom will increase, distance between each consecutive atom will increase. Now it will increase, so what will happen? This atom, they will go far, this atom, they will, so each consecutive, they will go far from each other. So overall what will happen? It will go like this, distance between all atom increases. Then size will increase. Now initial radius was, suppose here I am saying, initial radius is R. Then what is the final radius? You will say R into 1 plus alpha delta theta. Okay, because again, in the radius also you can take the chain of atom. In the radius also you can take the chain of atom. Now chain of atom is, suppose there is 100 chain of atom in the radius from center to the circumference, circum to the boundary. We have that 100 atom chain. Okay. Now what will happen when we will increase the temperature? Then each atom will go far from each other. Then suppose the total elongation will be what? 100x. Like this we can say. Now radius increase, it means volume increases. So here volume will not be the constant. Here that is the meaning of the thermal expansion, linear expansion, areal expansion, volume expansion. Everybody got? Okay, so angle we can say what? Arc upon radius. Initial alpha I can say y by r. Final I can say what? Final alpha. Okay, then I can say y final upon r final. Y is the linear dimension. Okay, then I can say what? Y into 1 plus alpha delta theta. And r final what I can say? R into 1 plus alpha delta theta. Now this factor will get cancelled out. What you got? Y by r. And y by r is what? Alpha. It means alpha will remain same. Everybody got or not? Are tell fast? Means it will be like this. Radius increases, y increases, but angle remain same. Suppose you have the small size pizza. Okay, small size pizza. How many slices are there? 4 slices are there. Okay, everybody getting? A small pizza. We have the 4 slices. Okay, what is the angle of the each slice? What is the angle made by the each slice at the center? A small size pizza, you have the 4 slices. Okay, so what is the angle made by the each slice at the center? 90 degree. Very good. Okay, so each slice will make the angle 90. Now same small size pizza same, but I make it big. I make it big size bigger, but still I am cutting the 4 slices. Okay, so I make the slice big, but I am cutting the 4 slices. Then also what will happen? What is the angle made by each slice? Then also the angle made by each slice will be 90. Now you can see this arc length increase, this radius increase, but angle remain same. Everybody got or not? That is happening there. Okay. So this completed. Okay. So for what I said, linear length or linear dimension, we can directly use the formula L delta L is equal to L alpha delta theta. Okay. Suppose you have the one steel disc. In that we have the one circular hole of radius r. If temperature increase, then what is the effect on the size of the hole? If the temperature increase, then effect on size of the hole. Increase, decrease, remain same. Increases. Why? What will happen after increasing the temperature? It will be like this. Suppose it expanded, and the size, this whole size will also. Don't think that it will go inside. It will go like this expansion. This whole disc got expanded, so hole will also get expand. So R increases and capital R also increases. Both hole size and the disc size will increase. Everybody got or not? Okay. Second part, what I am saying, suppose hole is fitted by brass disc. Okay. Suppose in this hole I have put the brass disc. Brass disc means exact same size. These things hard to visualize are just what you have to do. We are learning. We are learning the thermal expansion. Thermal expansion means after increasing the temperature, it will expand. Now, when it will expand, how it will expand? Now, suppose you are saying these two atom I am taking here and here. Okay, one atom I am taking here, one atom I am taking here. Now, when you will increase, what I said, the atoms will go far from each other. Now, this atom and this atom will go far from each other. Then what will happen? The diameter of the hole will increase. Diameter of the hole increase means radius of the hole will increase. Completed. Okay, what I said here, if the hole we are in the hole we put the brass disc. Yes, imagine as zooming the image. Very good. That we can do. Like suppose this, just zoom it. When you zoom it, then what you will get? You will get the size of the hole more, and then you will get the size of the disc also more. That is a expansion. That is a thermal expansion. Here, volume is not remain constant. You are keeping in the mind volume is constant. That's why you are unable to visualize. Okay. Now, second question, what I'm saying, suppose this hole, I have filled the brass disc. We have filled the brass disc in the hole. Okay. Now, I'm asking, everybody got? If hole, we have put the brass disc tightly. Okay. If I want to put the brass disc out, if I want to take the brass disc out, then we have to cool the whole system or we have to heat the whole system. To lose the brass disc, temperature of this system increases or decreases. That I'm asking. If, one more thing, maybe you don't have the idea, alpha brass is greater than alpha steel. Alpha brass is greater than alpha steel. That I gave alpha. This you also have to remember also, brass alpha will be more than brass steel alpha. So disc is made of steel. In that we have the hole. In that hole we have put the brass disc tightly. Okay. Now what I'm saying, I want to lose the brass disc. I want to take the brass disc out. Then we have to cool the whole system or we have to heat the whole system. Alpha brass I gave more than the alpha steel. We have to cool the system. Why? Brass disc is fitted. Okay. Alpha brass I gave more. So what I said, which material alpha more, it will expand more on heating and contract more on cooling. Okay. So now brass disc is fitted in the hole. If I will heat, then who will expand more? Then brass disc will expand more. Brass disc will expand more because alpha brass is more than the alpha steel. Okay. Everybody getting off? So hole size will increase according to the steel. Hole size will increase according to the steel, and the brass disc will expand according to the brass. Okay, because hole is in the steel disc. So when I'm increasing the temperature, hole size will increase according to the steel alpha, and the brass disc will expand according to the brass alpha. Who will expand more? Brass will expand more because alpha brass is more. So if I heat the whole system, then size of the brass disc will be more than the hole. So it will get more tight. It will get more tight. Okay. But I want to lose it. I want to lose it. Then what I will do? If I decrease the temperature, if I decrease the temperature, then both hole and the brass disc will contract. Who will contract more? Whose alpha is more? Alpha brass is more. Alpha brass is more. So alpha brass is more. Then when we will cool, it will contract. Who will contract more? Brass will contract more. Then it can get loose. Okay. Everybody got or not? So cool the system. Completed. So some numerical question we will discuss in the next class. Okay. Got it or not? Okay, numerical if you want, then in the linear expansion delta L formula you can try by own also. Okay, in the next class I will discuss some question and more concept on the expansion. Okay, okay then, bye bye. So right now homework is what? Homework, first you have to complete the whole thermometry part, thermal, and then read the whatever I discussed today, because question I will discuss in the next class. Okay? Bye, bye, bye.